Welcome back, Brilliant Mind. In the last video, we did cover the questions A and B, and now we move into 1.3. Okay, so 1.3 says, given that 2x squared plus p minus 3 in brackets multiplied by x plus 8 is equals to 0, determine the values of p for which the roots will be non-real. Now, this question is no different from 1.2. The only thing is that we're not given the question in a quadratic formula form, right? We're just given it in a quadratic equation form. So we do need to find our own discriminant here. Okay, let's move to 1.3. So 1.3, we are given 2x squared plus p minus 3 multiplied by x plus 8 is equals to 0. This is our quadratic equation, so we need to find our own discriminant to be able to answer the question, which says for the values of p which the roots will be non-real. So we know the roots are non-real if the discriminant is a negative. Roots non-real, the discriminant is a negative. What is the discriminant? B squared minus 4ac, right? So from the equation, we know that our a is 2. Our b is the coefficient of x, which is p minus 3. This is our b. And then our c is 8, which means our discriminant, which is b squared minus 4ac, would be the b being p minus 3 all squared minus 4 into 2 and 8. All right. So we have p minus 3 all squared. This is p minus 3 multiplied by p minus 3. 4 times 2 is 8. 8 times 8 is 64. So we would have minus 64 there. Right. We know that when we're multiplying two brackets, we just cross multiplying. And then this 3 will also multiply the p and the 3. Okay. So in other words, we are going to have p times p, which is p squared. P multiplied by minus 3, which is negative 3p. Negative 3 multiplied by p, negative 3p again. And then negative 3 times negative 3, which is a positive 9. Minus 64. Okay. Perfect. So now we have p squared minus 6p plus 9 and negative 64. And this will give us minus 55. Cool. So this is our discriminant. Our discriminant is p squared minus 6p minus 55. Now we said we want the values of p for which the equation will be non-real. In other words, the discriminant less than 0. The discriminant being what? P squared minus 6p minus 55 is less than 0. That is what we are solving for. Now, if we're solving for this, we can use the quadratic formula at this point where it's like you're solving for a, as like you're solving for x, but your x here is p. Or we just use our normal methods where we find the two roots, right? So this would be the two numbers that when we add them, they give us negative 6, but when we multiply them, they give us negative 55. And that is minus 11 plus a 5, because negative 11 times 5 is 55, minus 11 plus 5 is negative 6. Minus 55 less than 0. We further factorize this where we can look at this together and look at that together. So this would be p into p minus 11 plus what's common between the two is 5. So 5p divided by 5 is just p, and then 55 divided by 5 is just 11. So that is negative 11 because we have negative 55 less than 0. The two brackets are common, so we can factorize this further, simplify this further. We'll have p minus 11 and then p plus 5 less than 0. Now, when you get a question like this, you can sort of maybe draw a sketch, because this is your parabolic function. So you can sort of draw a sketch just to see that when you use your interval, you're using it correct. So our a is positive for this type of a function, which means it's a smiling function, right? So it is a function like this, where you will have your two roots there, right? Our roots here, we know our critical values, as they called, will be p is equals to 11 or p is equals to minus 5. So this is like your minus 5 and your 11. We're looking at the point where the graph is less than 0 and negative. So it's between these two roots. Therefore, this is negative 5. P is between negative 5 and 11. So we have solved the question, which asked us for which values of p will the roots be non-real. The roots are non-real when the discriminant is less than 0, and then we were not given the discriminant, so we had to calculate an expression for the discriminant, which led us to p squared minus 6p minus 55. Then we solved for the values of p, just as we solve for any quadratic equation. Solving for that, we got the critical values p is 11 and p is negative 5. Now, if you draw a rough sketch there where your a, because p here, your p squared is a positive p squared, which means your a is positive, therefore your graph is upward facing. Then we looked for those parts where the graph is less than 0 or is a negative, and then we saw it's between the two roots, negative 5 and 11. Hence your final answer is p is between negative 5 and 11. That will make the roots non-real. Thank you so much. Catch you on the next video.